So here with then the example of phase relationship examples as mentioned. So example 1, you have a sample with a diameter of 38 millimeters, a length of 76 millimeters, a mass, total mass, solid mass of solids, and then GS. The question is, what is the degree of saturation, what is the porosity, and what is the air content? I'm not going to go through all of the mathematics because the one follow logically onto the others and is just an extension or derivation of the formula that we already handled. So the degree of saturation can be defined as the volume of the water over the volume of the void. And then if you expand that, you get W, and therefore you can get E, which is the void ratio, and so on. And then in the end, you can calculate that the degree of saturation is equal to 98% saturated. Similarly, B, what is the porosity? It is defined in the top line, and if you substitute the values, you come to a 45% porosity. And similarly, C, which is the air content, is defined in the first line, substitute the values, and you get a 0.9% air content. Example 2, you have a certain volume, a certain mass of solids, and so on, and the degree of saturation is R, and what is the mass of the saturated material if you have no volume change. And again, it's a matter of substituting the values in the formula with the real values, and in the end you get a void ratio of 0.45, and in the end your saturated mass is 8.93 kilograms. There's another example of the unit weight gamma. So gamma